Okay, let's do the solution to problem 2. So here it is. It's just a graphing exercise. So we have to graph those functions. Let's start with a, which is a line. And let me go ahead and draw the axes. So there's the y-axis. Here's the x-axis. Let's call this x, call this y. And what we want to graph is the line y minus 2x. So, the form of a line is y equals mx plus b, and this is b, and b is always the y-intercept, so that thing is going through the y-axis here at 1. Okay, and so, an easy way to draw a line sometimes is just to connect the y-intercept and the x-intercept. So let's do that. It'll kill two birds in one stone, because we know that we have to find the x-intercepts eventually anyway. So let's solve that. So that's what we get when we plug in 0 for y. So we need to solve this relation. So 1 is equal to 2x, and this just means 1/2 is equal to x. And that gives us the y-intercept, so here's 1/2. Alright, and now we know 2 points in the line, so just connect those points and you've got the line. Let's see how well I can draw it. Not too bad. And that's it. That's it. So A is very easy. Now let's do B. Let me draw a y-axis here and an x-axis here. I'm going to label this x and label this y. And you can see that this B here is a line in disguise. You should think of it as a transformation of y equals x if you want. It's a shift right by 5. That kind of immediately tells you this x minus 5 is just a shift right by 5 of y equals x. So here is 5. That's going to be the x-intercept. Now if we want to know the y-intercept, all we have to do is plug in 0 for x, right? Plug in 0 for x and that will tell you the y-intercept. And if you do that, you get this 1/3 is going to come in and hit -5. So the y-intercept is minus 5 over 3. Okay, and I've got 2 points on the line, so I can just connect them and that's it. Okay, great. And moving on to C here. Okay, so C, we probably really should do C as a transformation of the parabola. Now I have to be a little bit careful, and this is the t-axis now instead of the x-axis, and now this is the y-axis. So this is a transformation of the regular, so maybe I should do it in a little animation here. So what if we first had t squared would look like this, right? This is t squared, but they've got minus t squared, right? See, it's minus t squared, and so that would turn it upside down. Alright, so this is minus t squared. And then what else do they do? There's a 1/2 there. So 1/2 would make it a little bit more broad. Okay, so this would be minus 1/2 t squared. And now what's the last thing they do? They add 1. Okay, so that would just push it up by 1. And so let me draw roughly what we're headed towards. It's going to be something like that. And let's just go ahead and draw that. Okay, so the y-intercept is 1 because they're pushing the parabola up by 1. It's going to be kind of broad. Okay, and so let me label this intercept. And now let's find the x-intercept, or in this case the t-intercept, these 2 points. Alright, so what do we have to do? We have to solve the equation 1 minus 1/2 t squared is equal to 0. Okay, so 1 equals 1/2 t squared, and so multiply both sides by 2, and you get 2 is equal to t squared. And so what does this mean? This means that t is just equal to plus or minus the square root of 2. So this must be the positive square root of 2, and this one must be the negative square root of 2. Okay, so we're done with C. And let's go on to D. So D is x squared minus 6x plus 6. So we've got f of x equals x squared minus 6x plus 6. Alright, and let's do this one using vertex form. So first let's find, the vertex is going to be h comma k. The vertex is where the parabola described by this quadratic is going to have its bump, or its little turnaround point. So we use the formula h is equal to minus b over 2a. So, b is negative 6, so this is going to be 6 over 2 equals 3. And what about k? K is going to be equal to f of h. And so in this case, that's f of 3. What happens when I plug 3 in here? I get 9 minus 18 plus 6. And you can see that that is going to come out to be negative 3. Right, because 9 and 6 make 15 and then negative 3. Okay, so I know that the vertex occurs at the point 3 minus 3. So let me go ahead and plot that on a graph. So here is a y-axis and here is an x-axis. So x, y. The vertex happens at 3, negative 3. Here it is. Okay. All right. And the leading coefficient a is 1. That tells me that it's an upward-facing parabola. But before I go ahead and do something dumb, there's a choice here between whether I make the y-intercept down here in the negative part or up in the positive part. I want my picture to look good, so I'm going to figure out the y-intercept before I draw anything. So as usual, you can figure out the y-intercept to this function by plugging 0 in for x. And pretty clearly, if you plug in 0 for x, the only thing that's left here is 6. And so the y-intercept is going to be 6. So let me make a little spot here at 6. Okay, and now I can draw things pretty well, or as well as I am able to with my shaky hands. And all I owe are the x-intercepts. So lots of ways to find those. We could use the quadratic formula, but let's just go ahead and solve the equation using vertex form. So remember, the vertex form is a times x minus h squared plus k. And a is 1 because the leading coefficient is 1. We saw that h is 3, and we know that k is minus 3. So let's fill all that stuff in. So we have x minus 3 squared minus 3. And to find the x-intercepts, we set that equal to 0 and solve. So that gives me x minus 3 squared is equal to 3. So x minus 3 is equal to plus or minus the square root of 3. And now finally, x is equal to 3 plus or minus the square root of 3. And so this one right here, must be 3 plus the square root of 3. And this one over here must just be 3 minus the square root of 3. And that's it. That's how you do number 2. So, oops, quit.